Cyclone preheater without immersion tube. What is the impact on kiln operations? On this occasion, we will explain the importance of the immersion tube in the cyclone preheater, and what effect it has on the clinker production process. What is the function of cyclone? The general function of a cyclone is to separate materials and hot gases in the preheater system. As shown in the figure, hot gas and material enter simultaneously through the cyclone connecting channel. Then a very fast vortex occurs inside the cyclone which separates the material and hot gas. Material exits through the bottom cyclone hole and hot gas exits through the inner tube, because there is air suction from the SPID fan. Before we continue this discussion, if you like this video material, please subscribe first and watch the video until it's finished, so you can find out what the impact of a preheater cyclone is without an immersion tube. Alright, let's continue this discussion. Why install an immersion tube in a cyclone preheater? The immersion tube has a very important role in determining the air vortex inside the cyclone, and the separation between the material and the hot gas. Avoiding unnecessary material recirculation, or less circulating material, is better. Better heat profile throughout the preheater tower, hot gas temperature between the upper level cyclone and the lower level cyclone is better. Lower exhaust gas temperature, due to better heat absorption in each cyclone. Increased production rates, due to less material recirculation. Immersion tube cyclones. The dimensions of the immersion tube size greatly affect the pressure of the air vortex inside the cyclone, and affect the efficiency of the cyclone. The longer the cyclone immersion tube, the higher the cyclone efficiency, but the pressure drop will also be high. So, the cyclone preheater design experts have also considered the dimensions of the cyclone, and the size of the immersion tube with the pressure drop and cyclone efficiency to be achieved. Example of a cyclone preheater. First stage cyclones, cyclones with high separation efficiency and low pressure drop are used as upper stage cyclones, where a separation efficiency of 95 to 97% is required. The cyclones in the lower and lower stages are specially designed to ensure low pressure loss. In these four cyclone images, the efficiency of stage 1 cyclones is around 95%, stage 2 cyclones are around 86%, middle stage cyclones are around 83%, and lower stage cyclones are around 78%. What makes the efficiency of this cyclone different is the size of the cyclone shape, and the length of the immersion tube between the stage 1 cyclone and the cyclone below it. In general, the cyclone tube stage 1 is longer, and the length of the immersion tube is around 70% of the inlet duct height. Stage 2 cyclone is around 65%, middle cyclone is around 60%, and lower stage cyclone is around 55% of the inlet duct height. That was an explanation about the function of the cyclone and the immersion tube. The question is, what is the impact on kiln operations, if there is no immersion tube at the bottom of the cyclone preheater? What parameter changes occur in the cyclone preheater? What is the impact on clinker quality and clinker production capacity? Operating parameters that occur in cyclone preheater is, material from cyclone 4 goes to the calciner, then the material and hot gas are separated in cyclone 5, but some of the material is circulated to cyclone 4 with the hot gas. So, that the material load in cyclone 4 increases, then the material returns to the calciner and to cyclone 5, most of the material enters the rotary kiln and some is circulated to cyclone 4. This change can be seen in the operating parameters of hot gas temperature and draft in calciner, in Cyclone 5 and in Cyclone 4, which are always fluctuations. This means that the material entering the rotary kiln is unstable. Impact on clinker quality. In clinker production, the material that enters the rotary kiln is unstable, making the thickness of the material inside the kiln uneven, sometimes too thick, and sometimes too thin. This causes the combustion process to be unstable, and the quality of the clinker also fluctuates. When the material flow is thin, passing through the sintering zone, the quality of clinker or free lime is below 1%, and when the material flow is thick, the free lime it can be more than 2%. This can be proven by keeping the speed of the rotary kiln, and the speed of the grate cooler constant, but the air pressure of the cooling fan sometimes goes up and sometimes goes down by itself. It can be seen in the clinker conveyor apron video. Sometimes the material is small, and the shape is granular, and sometimes there is a lot, but it is dusty or fine material. Due to fluctuating clinker quality, and clinker production capacity also decreased by up to 25% of installed capacity. Thank you for watching this video. Hopefully it's useful, and don't forget to subscribe, like and comment, and share it with your friends who need it. See you in the next video.